I, Vineeta Philip, Assistant Professor of Department of Electronics and Telecommunication Engineering, AISSMS, Institute of Information Technology, present my subsequent video titled Circular Convolution for Calculation of Linear Convolution and Aliasing Effect using MATLAB for the subject Digital Signal Processing. In this video, I would be discussing both the types of convolution with the help of numerical examples and demonstrating the same using MATLAB. We will also see as to how to arrive at the same answer using both type of convolution. Convolution of two sequences in time domain is equivalent to multiplication of their DFTs in the frequency domain. Here we take two data sequences x1 of n and x2 of n, each of length 4. These sequences are to be filtered, so we had to convolve the two sequences linearly. Linear convolution by using matrix method is as shown. Here each row element is multiplied with the corresponding column element. The result obtained is added by across the diagonal line, and we find that the result obtained by using linear convolution for this sequence is 1, 3, 6, 9, 7, 4, 0. If we want to make use of the FFT for reducing the number of computation, then we have to use the property of DFT, namely circular convolution property. Circular convolution property states that the multiplication of two DFTs will result in a circular convolution of the two sequences when reverted to time domain. So by following all these steps and performing circular convolution for the same two data sequences, we get the result as 8, 7, 6, 9. We find that the result of circular convolution is not same as linear convolution for the same set of sequences. So to obtain the same result using circular convolution, let the length of the first sequence x1 of n be L, x2 of n be M. The length must be made equal to L plus M minus 1 to obtain the same result using circular convolution. And then the length must be made in the power of 2 by 0 padding. So in our this example, L is 4, M is 4, so L plus M minus 1 becomes 7, making the length of sequence in power of 2 by 0 padding. We make both the sequences equal to length 8 by 0 padding. So our x1 of n becomes 1, 2, 3, 4, 0, 0, 0, 0, and x2 of n becomes 1, 1, 1, 0, 0, 0, 0, 0. Performing circular convolution by matrix method, we arrive at the same answer as that of linear convolution. Now let us see the MATLAB programming part, which first makes the length of both the sequence equal to L plus M minus 1. FFT of each of the sequence is taken, they are multiplied. Inverse FFT is taken, and finally we get the circularly convolved output. So here we have taken two sequences where x is 1, 1, 2, 1 and h is 1, 1, 0, 1. The MATLAB command available for performing convolution is conv. So by using this command, we take the convolution of x and h, display our linear convolution result, then perform 4-point circular convolution, for which we take FFT of x, store it in capital X, FFT of h and store it in capital H, apply a for loop, then take inverse FFT and display the absolute value of the final 4-point convolved result. Now if we want to make the results of linear and circular convolution same, then as we see here, we are going to pad zeros and make the length of our this sequence x1 and h1 as 8. Again taking FFT of each of the data sequence, applying a for loop, taking the inverse FFT and displaying the absolute value of the inverse FFT 8-point circular convolved output, we will arrive at the conclusion that we get the same results by using linear convolution and circular convolution. We see that according to sampling theorem in frequency domain, we must take the number of DFT points to be greater than L plus M minus 1, which in our this case is 4 plus 4 minus 1, which is 7. When we take the 8-point DFT, this condition is satisfied. There is no aliasing. When we take a 4-point DFT, there will be an overlapping of samples in time domain, and these overlapping samples will add up. The result using MATLAB program is as shown. The output of the linear convolution is 1, 2, 3, 4, 2, 2. Convolution result using 4-point DFT shows that sample 1 and sample 5 overlap to give the output as 1 plus 2 equal to 3. Sample 2 and sample 6 overlap to give the output as 2 plus 2 equal to 4. This is exactly aliasing effect in time domain. That's all for now. Stay tuned for many such videos on important concepts of DSP. Thank you for watching.